Well, disc brakes, they're the new tech on the block, and they're being put on all the new bikes, and they're phasing out rim brake bikes. And with all this hype going around about disc brakes, one of my followers actually asked, are disc brakes more aero? Now, that is actually a very good question, and we're going to look at some of the construction that we have on a bicycle to see if that really is the case or not. So keep watching, guys, and we'll roll our intro and then we'll dive right into it. Well, the first component we're going to look at is the wheels, and to keep things nice and simple, we're going to use the example that Campagnola has, which is the G3 wheel. Now this wheel has the same spoke arrangement on the back as it does on the front, so it's very, very simple. We don't have to think it like this one's different to the front, or is this one more cross-spoked or not the other one cross-spoked. So this is what I'm going to use as an example to demonstrate how the wheels, or the front wheel in particular, is different on a disc brake bike. Now, when you have a G3 Campagnola wheel, it has 21 spokes on the front and 21 spokes on the back because they're exactly the same construction. And on one side we have 14 spokes, which are in half the tension of the 7 other radial spokes, which are double the tension. And this is really good in the bicycle industry. And a lot of actual wheels are built like this because they give a doubling of tension, and it gives a very good balance to the wheel. Now let's just look at a rim brake construction. Now these wheels here that I have, Campagnola Boras, they actually have 18 spokes radial on the front, and then they have the G3 construction on the back. And if we count them up, we have 27 spokes on the back and we have 18 spokes on the front. So we're saving 3 spokes in the wheel. Then you might go, well, yeah, so what? 3 spokes, what difference does that make? Well, if you actually get your wheel on your bike and you turn your bike upside down and you give it a spin and you hold your hand near the wheel, you can feel that there's actually feels like a fan, right? Now the spokes are actually creating drag as they cut through the air because they're moving the air. And if you have more spokes, you create more drag. Now, I admittedly will agree, 3 spokes makes a very little difference. And as these spokes get higher and higher and higher, the difference actually becomes greater. So when you get down to 18 and you go to 16 spokes, the difference is actually very small. So the lower the number, the difference actually starts to drop off. Now let's just move on to the disc itself. Now the disc itself is actually a spinning mechanism. It's just like the wheel on a bike. And if you have gone and read up about how wheels on bikes work, you'll find that when the point at the bottom of the wheel is actually doing 0 speed, and the point at the top of the wheel is actually doing double the speed. So what actually happens is at the bottom of the wheel, the actual shape of the wheel or the aerodynamics of the wheel has a less of effect, because as the wheel's rotating towards the ground, it's slowing down. Then as it passes the point touching the ground, it speeds up. And at the top, we actually have the point of the highest rotation or the highest speed moving forward. So it's actually twice the bicycle speed. And what it does is at the top of the wheel, it actually creates a lot more turbulence at the top than it does at the bottom. Okay? Now the disc itself is also a spinning member and has exactly the same properties. So we actually have a disc that's very thin and it has holes in it quite often, and sometimes it even has irregularities on the end. So now we've got a spinning disc that's actually moving through the air at the top of that disc twice the speed of the bike, causing turbulence, right? Now let's just go back to a rim brake for a second. Now the rim brake, where does it sit? It sits on the front of the fork, just in this turbulent wake that's coming off the front of the top wheel. So even though the rim brake, when you look at it, looks like it's sticking out the front of the bike and it's not very aerodynamic, the rim brake actually is in a part of the bike where the air has already been turbulated, so it doesn't actually add very much to the drag of the bike. Whilst if we go to the disc in the centre of the wheel, it's actually creating quite a lot more turbulence at the centre of the wheel. And also behind the disc, there's actually a caliper, which in no way is designed in an aerodynamic fashion, because it needs to be designed to be able to have a hydraulic mechanism and a clamping mechanism to clamp the wheel. So that's not aerodynamic at all either. Right, now we've discussed the front wheel, and we've discussed the construction of the front wheel and the spokes, and we've discussed how like a spinning disc can actually create quite a lot of turbulence on the front of the fork. Now if you move to the rear of the bike, you'll actually find that they went to a wider dropout on the disc brake bikes, and it goes from 130mm for a normal rim brake bike to 135mm. So the bike is actually wider in the rear end. Now You know, people may argue, yeah, but you know, that's at the back of the bike and that's in turbulent air and that's going to make very little difference. And I 100% agree. You know, that's turbulent air at the back of the bike. That's why your derailleur shape and all that has very, very little effect because it's already turbulated air. But it's not going to give you an advantage. It's not going to give you an aero advantage making the bike wider. So in conclusion, if we look at all this stuff and we actually look at the wheel construction's got more spokes, we've actually got a disc spinning in the air that's actually at the top of the disc is spinning at twice the speed of the bike, and then we also have a wider bike on total because the back end is the widest part of the bike. There's no way that the bike can actually be more aero. Now we are talking about very small amounts here. It could be, you know, they claim aero handlebars can give you, you know, about 5 watts, okay? So it's probably a little bit of an exaggeration because manufacturers like to exaggerate. So let's just say at 5 watts. So if we applied that, you know, you probably, the spokes maybe could be 2, 3, it'd be, you know, single figures for sure. And probably the disc actually itself and the caliper probably has the biggest drag, and that could be maybe 5 watts. So you're probably going to get, you know, single figure wattage difference between the two bikes. But the disc brake will not be more aero, it just can't be. And even if you try and compensate that for, you know, the shapes of the frame, there's quite a huge limitations, because I don't know if people are aware, the UCI actually limit the way that they can make the frames, so they can't actually achieve a full NACA shape with the width and the actual length of the actual foil shape. So they actually, UCI, I don't know if people realise, UCI have actually put laws in to actually limit the ability of bike manufacturers to make the bikes fully aero. Well, anyway, so they can't make the gains there. Anyway, that's where I'm going to leave it. If you like these sort of tech videos on road cycling, remember to subscribe and ring that bell so you don't miss any more of my videos. Take care and keep riding, guys, and I hope you had a really wonderful Merry Christmas and enjoy your New Year. Cheers.